Okay, and then let me go ahead and pull this up really quick so everyone can see where to access our schedule. Give me one moment. So just in case everyone needs to know, so right here, remember to click the syllabus, or over on the left, syllabus. If you need to take a look and see what lab we're going to be performing, we're group C. Just give me 1 second while this loads. Okay, and then if you go all the way to the bottom, always, you can review your syllabus to make sure that you can see how everything's weighed. Everyone's doing really well so far from what I've seen. And looking down here, groups C lab schedule, the fractional and simple distillations, we performed those the past 2 weeks. And now this week, we're going to be going forward onto understanding the polarimeter. So make sure to review the syllabus in case you're curious of what we're going to be performing for the up and coming week. And then let me see really quick. So then switching back, I want to go ahead and touch on, I believe everyone's probably read it already, but I'm just going to go ahead and open this up for my sake and for your sake. Dr. Stogie emailed everyone in Canvas. Let me turn this 1 second. Share. Okay. So he said here, as per syllabus schedule calendar, the lab notebooks due this past Sunday for the simple distillation. Hopefully you completed. And then we would prefer if the fractional distillation was already turned in for the week prior. But if not, let me know if you had any situations going on during the past 2 weeks so that we can kind of accommodate, with everyone's situation. I know everyone had, some people had power and some people went through craziness. So just, keep communication with me. Don't be silent if you need any sort of extension and you had something come up. And so make sure to go forward and then complete all of the labs, up to now, the simple distillation, the fractional distillation, complete all the quizzes. And then, yeah, so that's the main thing that I wanted to discuss there. And I already emailed, well, let me cover that when we get to it. Let me open up the module here so that we can look at what we need to do. So we always go to module in Canvas, and then we open up this week, understanding polarimeter. Yes, so if you haven't completed the fractional or your simple distillation this past Sunday, if you haven't turned it in, then yes, the fractional distillation or simple distillation can be extended further. Just make sure to complete the lab notebooks as soon as possible. It shouldn't take too long. I know everyone has different situations going on, with regards to your power and internet connection and such. So just, keep open communication with me. Please don't just take advantage of the situation if you're behind. And I understand if you are due to the entire situation, but, just let me know. Say, hey, Scott, this is where I'm at. This is how much I've gotten done. And if you can please, lend me a helping hand in this situation, then, we'll keep going forward. But of course, don't take advantage of the good graces and make sure that you do end up utilizing the time as soon as possible. Either Canvas or Outlook is fine. I do get a lot of communications, so I may not immediately respond to people. So, but let me see really quick. And so let me go ahead and pull this up so I can stay focused on to what we need to look at today. So today we're going to be looking at, once again, yes, every lab that I record will be posted on my YouTube channel. So if anyone ever has an issue that something comes up, or if you're having, some internet connection issues or power issues, everything that I record here will be placed on my YouTube channel like usual. So then going forward, you're going to look here, and we're doing experiment 7 for this week, understanding the polarimeter and polarimetry. So number one, read through the lab manual and we will go ahead and go through it like usual there. Secondly, this video here is super important, the first one, and I want to go ahead and review that with you all here. And as well, of course, make sure to watch all of the little videos here. We won't cover every single one, but I do want to cover some important parts within this video so that you can get a visual representation of exactly what we'll be reviewing with regards to this experiment. So number one, we'll review Boyd's law whenever we go into the lab manual. So I'm going to go ahead and skip the starting parts because then she's just reviewing mainly what's, what the foundational principles are of polarimetry and Boyd's law. So secondly, this is what we would be doing in a laboratory setting. You would go ahead and take all of these different types of sugars, sucrose, lactose, and fructose. And this will be part of the second portion of the lab manual. We're going to be taking them and then we'd be placing them into these volumetric flasks. And so what you do is you'll weigh out your sample of a certain type of sugar, whether it be fructose, glucose, sucrose, galactose. You'd weigh it out firstly. Secondly, you take your empty volumetric flask and then you want to add in your sugar first, whichever type it is. And then you add in the DI water, such that if you were to add in your water first up to the little line, so you can very briefly see there's a little line here, and I would recommend to Google volumetric flask if you haven't seen one in person yet. So if you filled your water up to the line and then you add your sugar, then you'll be over the 100 milliliters. So then your solution is not equivalent to, as they say here, 10%, 20%, or 30%. Then it would be more dilute because you'd have more than 100 milliliters of water in there. So always put a little bit of DI water into a volumetric flask, then add in your solid, and then fill up the water up to the volumetric line such that it would make exactly the concentration that you're looking to get. Let me go ahead and address this. Oh yeah, so for this week, Shelby, we will go ahead and skip over the pre-lab just as I'm giving everyone a small pass this week just because I know everyone's still catching up with quizzes and tests and all this sorts of homework that everyone's had due to the weather situations. So we'll go ahead and move forward past that this week, but in the future weeks, we'll be checking, random people's pre-labs throughout. So going forward, oh, and also if you do ever miss any, like the starting portion of the lab, I post everything that's relevant from start to finish onto my YouTube. So go ahead and review this video from the portion that you missed beforehand if you need any clarification towards, some of the starting stuff. So yeah, here's all the separate volumetric flasks with different solutions in them that will be analyzed on the polarimeter. And then this pulled out right here is the polarimeter, the actual flask for the polarimeter. And it has a specific distance for it, which is 1 decimeter or 10 centimeters, 10 centimeters in a decimeter. So going forward, and then, I do still recommend everyone to go forward and review the full video, step-by-step, listen to it, analyze it so that you understand everything. I'm just here to give you a brief cut through of the main things that I want you to understand and maybe a deeper explanation that they may not give within it. Of course, this is a scale. So right here, you see, you put the 15 grams of your sucrose into a 50 milliliter volumetric flask, then you fill it up with water up to the volumetric line such that you would have exactly 50 milliliters, not 51 or 49 or anything around there. You want to make sure it's exactly at that amount. So going forward, there's just, weighing it out. Self-explanatory. This is what you would do in a lab setting. Then you'd place it in there and you see the liquid's not full yet. So they had it down there at the bottom and then you would fill it all the way up to the line. Let me see if they get to the point with the line. It's a little here. Hold on. Okay, well, they skipped it. Anyways, it should be filled up to the line. So we'll go ahead and go forward. Oh, actually, here you go. I think that they were just dissolving it. And then now they go straight up to the line and you just have to go kind of slowly. So that way that you minimize your error. because if you analyze something that's a little, more dilute than you expect or more concentrated than you expect, you'll end up getting incorrect results. And that's pretty important for anyone who's taking any analytical chemistry classes in the future. Quantitative analysis comes to mind if you may be having to take that class in the future. Then you'll be utilizing these techniques and have to be very precise. So finally, okay, let me scoot this back just a little bit because they cut into this pretty fast. Okay, on the left-hand side, this little podium thing that you see, this is the polarimeter. It looks like a little elevator or something like that. And then right here on the right, the rectangle, probably everyone's utilized this in Gen Chem, is the LabQuest. And there are connecting cables that are kind of like a USB or a Ethernet cable that plug into the LabQuest from the polarimeter. And that allows it transmit the data from the polarimeter over to your LabQuest and allows you to process that data in order for you to collect the specific angles that you need for these. And we'll go forward into the theory to understand what I mean whenever I'm talking about the angle of rotation of these. But let me go ahead. This is the meat right here that I wanted to show everyone, is exactly how we're going to transmit the data and how one would analyze if we were in a lab setting analyzing these sugars. So that's the polarimeter right here on the left. Here's the LabQuest on the right, as you can see on the top of it. Then you take the two cables that go from the polarimeter, plug them in to our LabQuest. And then this will give you like this little empty graph here. And this is just showing, where the data would show up when you do have your sample. So we take our initial sample here, and we would want to take our vessel and fill it with DI water. The reason that we do this is in order to create a blank. Blank is basically a standard that we utilize, which is deionized water. And it's so that if you were analyzing DI water alone, just the blank on this polarimeter through LabQuest, there's going to be a certain specific number that they give you. And what happens is, so with the DI water, we add in the type of sugar, and that sugar is going to have its own specific angle of rotation, such that the DI water is going to have also its base value, right? So that you can remove your blank, so that way that you can finally obtain only the value of the sugar. Otherwise, if you just threw on the sugar, constant, or the solution of sugar onto there, then you would only end up getting like everything combined, the blank and the sugar value. Okay, so let me just get this back just a little bit because I kept talking. So what they're going to do is now that your sample is placed into the polarimeter, she places her hand on top of the machine and rotates it. And what it does is it transmits the data. Once you hit play to record the data on LabQuest, and then you rotate it. And what it does is it rotates the angle around the flask itself and transmits this data over here. So we get the angle of rotation from the polarimeter transmitted to LabQuest. Secondly, and this is the important part that I wanted to kind of get into because this is pretty detailed. So we take it, and then we just take this specific section that we want to analyze. It's because it's a sinusoidal wave. We only need to analyze from the bottom over to the bottom of the second portion. And let me cut this back just because I go pretty fast. So I want to make sure nobody misses this. So you go to analyze. Okay, we're going to analyze the data, curve fit, just like we're using the TI calculator. If you were, if you threw up if you threw some scatter plot dots onto a TI calculator, and then you wanted to curve fit it such that you can find an equation through using a scientific calculator, then you can, utilize the computer that's within that system in order to transmit you the data and give you out an equation. So this takes the data from the polarimeter over into the LabQuest, and then we go to analyze, then we go to curve fit, and then illumination, which is just illumination is the illumination that's given out from the polarimeter. Then we have to choose which type of fit. And this is the important part for the LabQuest if you were doing this in a lab. We're going to be doing Gaussian because this is a Gaussian wave. So the Gaussian function is chosen here. And then the B value, only the B value is what we're going to be analyzing in order to get our specific angle of rotation. So this would be our blank. Then you would go forward and then you would run each individual sample. And it's just like anything else in analytical chemistry that you would just continuously over and over run the samples, save your data, write it down, and then you go forward to do your data analysis, with the given data. So, scooting forward, now they're just doing it again, going forward, they just keep going over and over. It's the exact same thing every single time. So understand, you plug everything up, you place your sample into the polarimeter, then you perform the experiment by rotating the polarimeter, then you select your wave from the bottom, and then it goes up to the top, and then it comes back down again. So you select specifically that section. Then you perform the analysis, best fit of your illumination, and then you run the Gaussian function. And then B, the letter B, as in boy, will be the one that gives you your specific angle of rotation. And then you have to remember that when you run your sample, then you have to remove it as such that you remove like a blank, or if you want to think about it in terms of our previous labs, when you have your filter paper weight, remember you have to remove it so that you know how much your sample weighs. It's the same thing here, such that you need to remove the blank so that you can find out your specific angle. So I'm going to stop that for a sec and then pull up the lab manual so that way we can review it like we usually do. And this one is pretty simple this week, so we will not be here for too long, but I think I would like to utilize the extra time that we have in case, because I know that there's been a lot of confusion in the past 2 weeks, and I hope everyone's doing all right. Y'all are doing a great job. I just wanted to say thank you, for showing back up. I know it's been really tough this past 2 weeks, but I'm here to help you guys. So just feel free to reach out to me if you need any help, with understanding any of the material or any assistance with creating the documents at hand that we need to, so everyone can have a smooth ride through this. So let me switch this over. So understanding polarimetry. This is a short little one, and we're going to go ahead and go forward. As usual, they have a good purpose section and understanding and the reasoning that we do this. So if you're a biochemist by chance, or you work with the amino acids, nucleic acids, carbs, lipids, they're all optically active, and these are great to analyze. And the way that you can do this very simply in a lab is by using the polarimetry, by using a polarimeter system. Oh yeah, and so like one thing as well, make sure on your lab notebooks, it looks like everyone's doing like better and better. Everyone's understanding more about what to do. Make sure to review my past 2 videos if you haven't seen them yet. I think actually last week I went through like an in-depth analysis of a lab notebook example. You can also go over here, and let me pull this up really quick just so that way I can get this out, because I just thought about this and forgot to mention at the beginning of class for y'all, because I teach another class in the morning. So if you come over here, let me share this really quick. Go to Files, then Lab Notebook Example, and then you can see here a great lab notebook example. And also, you can review the video from last week where I go through an in-depth analysis of that. And for future classes, I'm definitely going to do it just so that way everyone knows exactly what to place in there. But yeah, go ahead and review that video if you need to, or go into Canvas and review that specific link. Otherwise, y'all are doing pretty good so far on the notebooks and doing great on the quizzes. I know they can get a little tough, but just always feel free to reach out and ask me if you need any assistance. So going forward, the main concept here that's performing is a light is going through a fixed polarizer, and it goes through a sample tube that holds our optically active samples, such as the sugars that we'd be analyzing here. And then it goes through an analyzer and detector that analyzes the specific degree of rotation of which that specific molecule on a compound emits light. So it is always at a specific angle. So you can always think about it like a clock, like rotating left and right, and which way that it rotates is a specific angle from set 0. And then if you go clockwise, then it's positive, but if you go counterclockwise, it's negative. And I'm seeing myself in the camera right now, and it's kind of going the other way. But think about it like a clock And so clockwise to the right is positive and counterclockwise to the left is negative. So that's a great example here that I wanted to mainly describe. This is the biggest portion of the concept that we're understanding with polarimetry, is that a positive enantiomer rotates the plane of linearly polarized light clockwise, like I said before. Dextro, I don't have a good example of how to remember dextro, but I have a great example of how you can remember levo. Levo is left. That's just remember L and L. Levo is left, and it's negative. So a negative enantiomer rotates the plane counterclockwise, or levo, to the left. And then, dextro is to the right. So you just have to figure out how to remember the word dextro and relate it to turning right or clockwise. So going forward, the way that we utilize this once we've taken our angle is that we use this thing called Boyd's law, such that the alpha is the observed optical rotation in units of degrees, which is right here, this alpha, the first one. Then alpha in parentheses is the specific rotation and units of degrees, where the formal unit for specific rotation is degrees. Decimeter, remember always if they give you centimeters, so if you have a 10 centimeter volume of sample, what is called sample tube. Yeah, if you have a 10 centimeter sample tube, that's 1 decimeter. So always convert from centimeter to decimeter when you do these calculations, so that way that you don't mess up the Boyd's law and then you get too large of a sample, because if you're using 10 centimeter instead of 1 decimeter, you're gonna end up getting 10 times the angle that you'll get in degrees. And so it's degrees per decimeter, milliliter per gram. And they say going forward, the length, L is the length of a cell in units of decimeter. Always remember decimeter, not centimeters, so always convert. And C is the sample concentration in units of grams per milliliter. So going forward, that's pretty much it. I mean, see, it's like mainly this is why I'm really hitting home the point for this week to briefly review the lab manual so you understand Boyd's law, and then understand the difference between Devo plus clockwise and dextro clockwise, right, positive, levo left, counterclockwise, negative. And then remember Boyd's law, alpha times the path length, which is in decimeter, times the concentration. So just remember those, and then you'll get through this smooth sail. The main thing that we're going to do is make sure to be detailed with your notebook with regards to explaining out the reason that we're performing this experiment. Going into your materials, make sure that you put the machines. The machines are only machines that we utilize in order to perform analysis, such as the LabQuest or the LabQuest app or Logger Pro, and the Vernier polarimeter. Polarimeter is the machine, and then but the thing is, the polarimeter sample cell is the apparatus. So that is like basically the round bottom flask let me go back and review our simple distillation. The round bottom flask that we put our solution into, that is our apparatus. And the heating plate or the heating mantle is the machine that we utilize to perform the experiment. The apparatus is just what the experiment is performed in. And make sure to, when you also list out all of your apparatuses, that you list out the specific volumes. So 50 milliliter volumetric flask, 50 milliliter graduated cylinder. Make sure to just be extremely specific on it, such that if you created this lab notebook and once you were done with it, you could literally hand it over to your buddy and say, hey, walk in the lab and perform this experiment. And they could do start to finish and be able to do it without asking you any questions. So that is the utmost part of which that I would say that a perfect lab notebook is. And we did have a few that people that did great. And I would say that most of you all did very good, which is good news to me. That means that you have good experience in the past from your Gen Chem labs, and I'm glad to see that. So, just keep going forward. And if you have any specific questions with regards to any sections, just let me know, and we'll get into a deep discussion of that. And I can just give you a good overview. And I don't mind if I need to repeat myself 100 times. I'd rather be that teacher that helps you with something instead of just neglects the person and lets them fall into the water. Because I've had that before, and I would rather see everyone succeed and learn from this class, not suffer. So make sure to give a lot of detail with this, because you'll see it as I keep scrolling. It's just a lot of procedure, a lot of procedure. Weigh your stuff out, connect your cables, calibrate the polarimeter, record the angle. Then you perform your analysis of your curve fit on the illumination such that you perform the Gaussian fit, and then you take B as your angle, and then that will be the specific unit that you need to be utilizing in order to perform these equations. One moment here. Yes, so beakers are apparatuses, and the machines are only the machines that are used within the experiment. So in this one, polarimeter, the LabQuest, the scale, those are machines. The apparatus is like the beaker, volumetric flask, graduated cylinder, all of the glassware. And always, like I said before, and I'll repeat it a million times, always feel free to reach out to me. And if you just say, hey, Scott, I'm super confused. Is a heating mantle a machine or an apparatus? And I might even just treat it like a text message, just say machine, just send that straight to you. So that way, because it takes me 2 seconds to respond, and that way I don't have to, go through creating you an elaborate essay on what type of scale this is and how calibrated it is. Some of these things we don't want to make them too overcomplicated. So yeah, always feel free to speak up or type in the chat, and then we can hash it out. There might always be people who have the same question that you're thinking of, and they might be afraid of asking it. If I read all the work on the data sheet, do I still have to fill out the post-lab calculations section? So for the data, okay, yeah. So I see what you're asking now. Yeah. So upload that or transmit it, whichever way that you perform it. If you're using the physical copy, then you need to scan it within as well and make it into one big document. Or if you take the sheet and you could place it into a Word document as a photo, that's fine for me too. Whichever way that you get all of the lab questions up on there, the post-lab questions within your lab notebook, such that if somebody wanted to review it at the end and they were like, oh, I need to understand the concepts of the material that we discussed throughout this whole procedure. Why did we perform this experiment? That they can look at your lab notebook, go to the very end, the post-lab questions. Oh, okay, that's why we don't want to place a hot solution into cold ice bath, because not only will it ruin our recrystallization by allowing the impurities to come out, it also would shatter the beaker. So something like that. The setup that we have here is to teach students how to perform good research, because what happens is that we perform all these experiments and we need to write it down, so that way that if we go forward and somebody wants to replicate these procedures, then they can take our experimental or our lab notebook and they can go forward and perform the exact same thing. And sometimes we get caught up in research with doing so much stuff that we don't fill out our lab notebook, but it's just a critical thing that we need to make sure that we all do, so that way people can replicate our experiments. So going forward, yeah, this is all basically setting up your Logger Pro and everything, and then analyzing the data. So make sure that you list out all the stuff in your own words within your procedure. Everyone's been doing very well with doing that. And then finally, we come down to our data tables here. Let me zoom out a little because it's a little scroll too much. So put all your data into your data tables. And if Dr. Rastogi provides you with data like that where we have the unknown and we were like missing an extra one, then yeah, just cross out the table, or just don't include like an extra one in case that portion of data is not provided. We just skip it and go forward. So then the data analysis, this is basically the portion here of how you would analyze the data to calculate the specific rotation. So make sure to perform this data analysis section with regards to the data that we give you. And then here's the part, and this is critical, so make sure everyone listens closely here, because there is a second portion here that will be on another section. So what I want you to do is one of two things. You can either put both together and make a giant procedure that'll analyze both data sets, or you need to make, run through the full materials, everything like that, procedure or machines, apparatus, procedure, data analysis, and then do it again with this stuff, with the objective material, machines, apparatus, and procedure, data analysis. So either do 2 of them separate within the same Word document or lab notebook that you have, or combine them and then do it all as one big project. Either one works for me. I know it's a little confusing because you're going to see it. Either way, I want to make sure that everyone just remembers, do both parts, because it's super fast. Since you already have the data, this is super fast. All it is you just writing out everything. So I want to make sure nobody misses that this is critical. So let me see. So should I copy the procedures from the manual into my notebook? Yes. So I want you to take the procedure and then reword it in your own words, so that way you're not performing plagiarism. So just try and reword it as best as you can. I know it's really difficult when it's something like weigh a sample of 2 grams. Just try to phrase it whichever way that you can, so that way that it's unique. Does the data analysis go in the post-lab calculations? Yeah, so you can either have it like as data analysis section, or you can say post-lab calculations. Either way that you phrase it, as long as all of the questions that need to be answered are within your lab notebook, then you're good to go. So going forward, then right here, the same situation, we have the similar objectives, just this time we're performing the analysis of sugar samples. And then here are our apparatus and our machines. Make sure also for this one, the hazard, it's going to be a little ambiguous. Just if you can get something small for the sugars, just write down maybe if it says like skin irritation or something. I'm not really sure how dangerous any of these sugars, particularly would be, but they are aqueous waste, and they're sugar. It's not like something as much as we need to worry about other labs where we had like cyclohexane or flammable materials. These are not flammable. They're just water soluble sugars. And all these are real life examples of stuff that are in food and such. So just give a little brief hazards example here for just name amounts, just for formality, so everyone understands what to do within a given procedure. Then go forward, and then here's it's another extra little procedure here. So actually, it's not as bad as I thought it would be originally. You could just put like procedure part 2 sugar or something like that, so you can kind of combine your sections, or you could just separate it, whichever way. I know that everyone's going to be confused when they look back at it and be like, wait, why is there 2 parts to this? But please make sure, do both parts within your lab notebook when you submit it, just so that way nobody loses any points for not performing the second portion of this. Just always utilize your lab manual when you are performing the lab notebook. And then finally, the data tables here of this last part. And then let me switch back over to the data. Okay, so right here, data tables, if your name starts with A through I, you'll go through here. Your angle blank is like the DI water, and for part A, and then for here, part B, and then over here, J through R, part A right here, and part B. And I did have one student already ask me, I don't know exactly why the data that was provided is so staunchly different between 178 and 121. That would not be usual within a lab setting. Something must have happened with calibration, or maybe it was just trying to make sure that people utilize different data. And then finally, let me open this last one. Okay, S through Z, first name. You'll utilize these numbers and make sure to fill out these tables and perform the calculations for each. So yeah, this week it's kind of cut short. It's not too much stuff. So going forward, I'll try and think here for a second if I need to address any specific situations. Make sure you just give a good detailed analysis in your lab notebook, so that way you earn the most points possible, and to review on Canvas in files in lab notebook if you need a good example. It looks like everyone's doing really great so far in the class. I want to say thank you for showing up today. I know it's been not only a tough year, but a really tough semester, especially here in Texas with all the craziness. Just want to say thank you to everyone for coming out. And yeah, pretty much we're done here for today. So if you have any further questions, we can speak up now, and otherwise everyone is free to head out.
I have a question.
Yes.
So I filled out my data table and I like wrote on it and stuff, and I kind of did all the calculations. So can I just do I have to do the